Today topic is 7QC tools. Essentials of lean manufacturing. In this video we will discuss about history of quality journey. This is part 8 training video of 7QC tools. Introduction of 7QC tools. 7QC tools are simple statistical tools used for problem solving. Developed in Japan by quality gurus such as Deming and Juran. Most useful tools for problem solving. As per Koru Ishikawa, these 7QC tools can be used to solve 95% of all problems. These tools have been the foundation of Japan's industrial resurgence after the Second World War. Content. A brief about quality. Problem-solving approach. Basic statistical concepts. 7 quality control tools or problem-solving tools are: check sheet, stratification, Pareto chart, cause and effect diagram, scatter plot, histogram, control chart. What is quality? It can be described into different ways. One is product features that meet customer needs. And second is freedom from deficiencies. Product features which helps to increase customer satisfaction, make products saleable, meet competition, increase market share, provide sales income, secure premium prices. Freedom from deficiencies helps to reduce field failures, reduce rework waste, reduce error rate, reduce customer dissatisfaction, reduce inspection test, shorten new products launch time, increase yields capacity, improve delivery performance. Quality means those features of products which meet customer needs and thereby provide customer satisfaction. In this sense, the meaning of quality is oriented to income. The purpose of such higher quality is to provide greater customer satisfaction and, one hopes, to increase income. However, providing more and or better quality features usually requires an investment and hence usually involves increases in costs. Higher quality in this sense usually costs more. For instance, if the mobile purchaser believes the unit exceeds all the needs and expectations he or she had for the mobile when it was purchased, then the customer is satisfied with the unit's quality. Quality means freedom from deficiencies, freedom from errors that require doing work over again, rework, or that result in field failures, customer dissatisfaction, customer claims, and so on. In this sense, the meaning of quality is oriented to costs, and higher quality usually costs less. One definition that makes sense is fitness for use. Here the user of a product or service can be an individual, a manufacturer, a retailer, or the like. For instance, an individual who purchases a car or motorcycle or high-definition television set or a mobile phone expects the unit to be defect-free and to provide years of reliable, high-performance service. If the car, the bike, the TV or mobile performs as desired, it is fit for use. Quality, the totality of features and characteristics of a product or service that bear on its ability to satisfy stated or implied needs. Not to be mistaken for degree of excellence or fitness for use, which meet only. Next we will discuss about definitions of other keywords. The definitions of quality include certain keywords that themselves require definition. Product, the output of any process. To many economists, products include both goods and services. However, under popular usage, product often means goods only. Product feature, a property possessed by goods or services that is intended to meet customer needs. Customer, anyone who is affected by the product or by the process used to produce the product. Customers may be external or internal. Customer satisfaction, a state of affairs in which customers feel that their expectations have been met by the product features. Deficiency, any fault, defect or error that impairs a product's fitness for use. Deficiencies take such forms as office errors, factory scrap, power outages, failures to meet delivery dates, and inoperable goods. Customer dissatisfaction, a state of affairs in which deficiencies in goods or services result in customer annoyance, complaints, claims. Next we will discuss about historical progress in quality. Quality journey starts in 17th to 18th century. In this phase the craftsmanship and small-scale production started. They emphasis on the role of master craftsmen and their pride in workmanship. In 17th to 18th century, master craftsmen and their apprentices were responsible for designing and building products. Quantities of goods produced were small, and product quality was controlled by expert workmanship. Master craftsmen had a great deal of pride in their work, and quality was not a problem. Much of the early work in quality control was done at Bell Telephone, now known as American Telephone and Telegraph, or at T. The Bell System and Western Electric, the manufacturing arm of Bell Telephone, formed the inspection engineering department to deal with quality problems. However, the introduction of mass production in the late 18th centuries and early 19th centuries changed things. Production processes became very complex, with many workers, rather than one skilled craftsman, responsible for the final product. Inevitably, product quality characteristics displayed variation. In particular, Henry Ford developed the moving assembly line at Ford Motor Company. As assembly line manufacturing spread, quality became a problem. Production managers were rewarded for meeting production quotas, and quality suffered. To make mass-produced products more consistent, inspectors were hired to check product quality. However, 100% inspection proved to be costly, and people started to look for alternatives. Then in 19th centuries to 20th century. In 1920 Harold F. Dodge and Harold G. Romig, also of Bell Telephone Laboratories, introduced statistical acceptance sampling, a statistical sampling technique that enables a company to accept or reject a quantity of goods, called a lot, without inspecting the entire lot. In 1924 Walter Shewhart of Bell Telephone Laboratories introduced the concept of statistical quality control, controlling quality of mass-produced goods. Shewhart believed that variation always exists in manufactured products, and that the variation can be studied, monitored, and controlled using statistics. In particular, Shewhart developed a statistical tool called the control chart. Such a chart is a graph that can tell a company when a process needs to be adjusted and when the process should be left alone. During World War II, statistical quality control became widespread. Faced with the task of producing large quantities of high-quality war material, industry turned to statistical methods, failure analysis, vendor certification, and early product design. The U.S. War Department required that suppliers of bore material employ acceptance sampling, and its use became commonplace. Statistical control charts were also used, although not as widely as acceptance sampling. In 1946, the American Society for Quality Control, ASQC, was established to encourage the use of quality improvement methods. The organization sponsors training programs, seminars, and publications dealing with quality issues. In spite of the efforts of the ASQC, however, interest in quality in American industry diminished after the war. American business had little competition in the world market. Europe and Japan were rebuilding their shattered economies. Tremendous emphasis was placed on increased production because firms were often unable to meet the demand for their products. Profits were high, and the concern for quality waned. As a result, post-war, American managers did not understand the importance of quality and process improvement, and they were not informed about quality improvement techniques. However, events in Japan took a different turn. After the war, Japanese industrial capacity was crippled. Productivity was very low, and products were of notoriously bad quality. In those days, products stamped "Made in Japan" were generally considered to be cheap junk. The man credited with turning this situation around is W. Edwards Deming. Deming, born in 1900, earned a Ph.D. in mathematical physics from Yale University in 1927. He then went to work in a Department of Agriculture affiliated laboratory. Deming, who had learned statistics while studying physics, applied statistics to experiments conducted at the laboratory. Through this work, Deming was introduced to Walter Shewhart, who explained his theories about using statistical control charts to improve quality and productivity. During World War II, Deming was largely responsible for teaching 35,000 American engineers and technical people how to use statistics to improve the quality of bore material. After the war, the Allied Command sent a group of these engineers to Japan. Their mission was to improve the Japanese communication system. In doing so, the engineers employed the statistical methods they had learned, and Deming's work was brought to the attention of the Union of Japanese Scientists and Engineers, JUS. Deming, who had started his own consulting firm in 1946, was asked by the JUS to help increase Japanese productivity. In July 1950, Deming traveled to Japan and gave a series of lectures titled Elementary Principles of the Statistical Control of Quality to a group of 230 Japanese managers. Deming taught the Japanese how to use statistics to determine how well a system can perform, and taught them how to design process improvements to make the system operate better and more efficiently. He also taught the Japanese that the more quality a producer builds into a product, the less it costs. Realizing the serious nature of their economic crisis, the Japanese adopted Deming's ideas as a philosophy of doing business. Through Deming, the Japanese found that by listening to the wants and needs of consumers and by using statistical methods for process improvement in production, they could export high-quality products to the world market. By the 1970s, the quality of many Japanese and European products, for instance, automobiles, television sets, and electronic equipment, became far superior to their American-made counterparts. While Deming was famous in Japan, he was relatively unknown in the United States until 1980. In June 1980, Deming was featured in an NBC television documentary titled If Japan Can, Why Can't We? This program, written and narrated by then NBC correspondent Lloyd Dobbins, compared Japanese and American industrial productivity and credited Deming for Japan's success. Within days, demand for Deming's consulting services skyrocketed. Deming consulted with many major U.S. firms. Among these firms are the Ford Motor Company, General Motors Corporation, and the Procter & Gamble Company. Ford, for instance, began consulting with Deming in 1981. Donald Peterson, who was Ford's chairman and chief executive officer at the time, became a Deming disciple. By following the Deming philosophy, Ford, which was losing $2 billion yearly in 1980, the 1980s saw many U.S. companies adopt a philosophy of continuous improvement of quality and productivity in all areas of their businesses: manufacturing, accounting, sales, finance, personnel, marketing, customer service, maintenance, and so forth. This overall approach of applying quality principles to all company activities is called Total Quality Management, TQM, or Total Quality Control, TQC. It is becoming an important management strategy in American business. Dr. Deming taught seminars on quality improvement for managers and statisticians until his death on December 20, 1993. Deming's work resulted in widespread changes in both the structure of the world economy and the ways in which American businesses are managed. In 1988, the first Malcolm Baldrige National Quality Awards were presented. These awards, presented by the U.S. Commerce Department, are named for the late Malcolm Baldrige, who was Commerce Secretary during the Reagan administration. The awards were established to promote quality awareness, to recognize quality achievements by U.S. companies, and to publicize successful quality strategies. The Malcolm Baldrige National Quality Award Consortium, formed by the ASQC, now known as the ASQ, and the American Productivity and Quality Center, administers the award. Finally, the 1990s saw the adoption of an international quality standards system called ISO 9000. More than 90 countries around the globe have adopted the ISO 9000 series of standards for their companies, as have many multinational corporations, including AT&T, 3M, IBM, Motorola, and DuPont. This is all about history of quality journey. In next video we will discuss about 7-quality tools. So don't miss these videos for complete understanding. Thank you for watching.